Welcome back, Virtual Pre-Calculus. This is section 8.3, part 2. We're going to learn some new tricks. Actually, we're going to be reusing some old tricks in a new situation. So let's take a look at example 6 it is in your section. Sine of 2x is root 2 over 2. Now the root 2 over 2 part is really familiar, and the 2x is a bit odd. Those of you that were studying the double angle identities, you three, you may think of another way to handle this, but here's the way we're going to do it now. We're going to use a trick called substitution. Basically, we're just going to say, look, I wish it said x instead of 2x, so let's just pick a new variable that's twice the other one and call it u. And then that allows us to rewrite our equation as the sine of u is root 2 over 2. Now this we can solve without a calculator. Of course, we could use a calculator, but we know that 45 degrees or pi over 4 radians is one of the answers to this. Okay, what's the other answer? What quadrant is it in? It's got to be in the second quadrant, right? Because sine has to be positive. ASTC, all students take calculus, sine is positive in the second quadrant as well as the first. So, what is the angle in the second quadrant with that reference angle? That's right, 3 pi over 4. That's a 3. Okay, so pi over 4 or 3 pi over 4. But we don't want u. U is something we just made up. If u is this or this, x has got to be what? Well, half as much, right? U is twice as big as x. So if u is pi over 4, x is half of that, or pi over 8. If u is 3 pi over 4, x is half of that, or 3 pi over 8. Okay? And of course, if we want to, like your book does in the example, we can add a 2 pi n to either of those to show all the solutions. Okay? If the question says, find all the solutions, then you have to do that. If the question says, find all the solutions between 0 and 2 pi radians, then you don't, right? Then you only need the first pair. Okay? So just keep an eye out as to what exactly it's asking for, and you'll be fine. Alright? So have another look at that, see if that makes sense. Pause it if you like. Okay, we're going to do another example that also uses substitution. I believe it's example 7 in your book. And some of you are probably going to figure out this trick before I even tell you, because you've seen it so many times before. You now have seen this thing enough to know that this is a quadratic equation in disguise, right? If we could just have it be 3x squared minus x minus 2 equals 0, that would be easy. So that's what we're going to do. We're going to make that happen with a substitution. What substitution do you think we're going to make? Yes. U is equal to sine of x. Okay, so with that substitution, that first term is going to become 3u squared. Okay, and then minus sine x, so minus u. And nothing happens to the 2. It just stays a 2 equals 0. Okay, so we know how to factor this, I hope. Come on, Kolpak. 3u plus 2, I think. And u minus 1. Let's see if that works. I get my 3u squared, 2 minus 3. Yeah, it works. So that means u has to be, well, alright, 3u plus 2 has to be 0, in which case, if you work that out, u is going to be negative 2/3. Or u minus 1 is 0, in which case u is equal to 1. So u is either this or this. Now how do we figure out what x is? Right? You always have this part in solving a problem with substitution where you go back to your original substitution. This was the thing we decided to do. So we know our u's now. We can use this to solve for our x's. We know that negative 2/3 is sine x, or 1 is sine x. Now this is easy. There's only one place where this happens. x has to be pi over 2 plus 2 pi n. For that to happen, right? That's the only place where sine becomes 1. Negative 2/3. That's definitely a job for the calculator. We take the inverse sine of negative 2/3. And we find, try that, make sure your calculator is working the way you think it is. We find negative 0.7297. And then we're back in the position of saying, hang on, there's probably another place in this unit circle where sine is equal to negative 2/3. Right? What quadrant is that going to be in? Well, this is in quadrant 4, so we got to find the quadrant 3 version. So again, like we did before, we're going to say, look, this is negative x, so x would be positive 0.7297, and our quadrant 3 version is going to be pi plus x. Okay, pi plus 0.7297, which is 3.8713. And we could add 2 pi n to all of these guys. Sorry, this board is really, really small. I got it super cheap at the CVS down the street. So it's all I've got. Okay, so we have 3 sets of solutions here. Okay, and they're all important to the answer. This answer gets all the solutions forever and ever. That's what the 2 pi n is all about. Okay? So back up and try that again yourself if you think you need to. Otherwise, you can graduate to part 3, which is going to be another set of tricks. Alright, so I'll see you then. Kolpak out.